Hello, hello everyone. See, in today's lecture, we are going to discuss basicity of amines. We know amines are basic in nature as there is a electronegative nitrogen atom is present in most of the organic bases. So that nitrogen atom is having unshared pair of electron. So that unshared pair of electron can be used for acceptance of proton. Hence, we are saying that most of the organic bases are having what? Nitrogen atom. So here in this lecture we have to discuss basicity of amines. So let us discuss basicity of amines in more detail. See, we know base is a substance that can accept a proton by donating a pair of electron. Base is a substance that can accept proton by donation of what? Unshared pair of electron. Ammonia is the simplest nitrogen base. Ammonia is the simplest nitrogen base and has a pKAH. Okay, pKAH. Okay, see this pKa, I am not mentioning here pKa only. I am mentioning here it's what? pKAH. H means what? This is a pKa value of its conjugate acid. Okay, pKAH means what? pKa value of its what? this its measure of acidity of it what? Its conjugate acid. So pKAH value for this ammonia is how much? 9.24. Any substance that increases the electron density on nitrogen, any substance that increases any substance that increases electron density on what? Nitrogen, that increases, that means that will raises the energy of the lone pair. Okay, so any substance increases the electron density on what? Nitrogen atom, so that will rise the energy of what? An unshared pair of electron, thus making it more available for protonation and increasing the basicity of amine, so that amine will have what? Larger pKAH values. Okay, so any factor, that factor, it may be a electron donating group, or it may be a what? Electron donation through what? Resonance. Okay, so electron donation through what? Either sigma bond, or electron donation through what? Resonance, or it may be a steric factor. If any such factor which increases electron density over what? Nitrogen atom, that compound or that nitrogenous base will be a what? Stronger base, okay, than the other counterparts. So conversely, any substituent that withdraws, okay, any substance that what? Withdraws electron density from nitrogen. Okay, if any substance that withdrawing electron density from nitrogen atom, that will be what? Less basic, and that will have smaller pKAH values. Okay, so here I have mention that for a stronger base we are having what? Higher pK value. For a stronger base it should have what? Higher pKAH values, and it have what? Low pKb value. PKb, if we are measuring basicity in terms of what? PKb value, then that pKb value should be lower. Okay, but if we are measuring basicity by what? pK value, then that base, stronger base, should have what? Higher pK value. In case of acidity, we have seen if a acid is stronger, that acid should have lower pK value. Okay, and see, remember here we are measuring basicity of amines by what? pKAH value. Here pKAH means what? Dissociation constant for conjugate acid of that base. Okay, after donation of proton, after donation of lone pair toward proton, or we can say in other words, after acceptance of proton by base, that will form a conjugate acid. That will form what? A conjugate acid. Now that conjugate acid is what? A acidic. Okay, when it will lose proton, when that conjugate acid will lose proton, that will be what? Its measure of acidity of that conjugate acid. But that is used for measuring basicity of amines, measuring basicity of bases. So pKAH means what? pKAH means what? It's a measurement of basicity of amines or a bases by dissociation of its conjugate acids, isn't it? So this is pKH. So I hope you have understood this basis background related to basic compounds. Now see, the expected order for basicity of amines is like this. Ammonia is weaker base than primary amine. Primary amine is weaker base than secondary amine, and secondary amine is weaker base than tertiary amine. So in other words, we can say that tertiary amine is more stronger base than secondary amine. Secondary amine is more stronger base than primary amine, and primary amine is more stronger base than ammonia. This what we are expecting, as we know alkyl group. Okay, in primary amine there is one alkyl group, in secondary amine there are two alkyl group, and in tertiary amine there are three alkyl groups. So these alkyl groups are increasing electron density over electronegative nitrogen atom. These alkyl group are increasing electron density over what? Electronegative nitrogen atom. So thus they are rising the energy of lone pairs. Okay, so that lone pair of electron are what? More available for acceptance of proton. Hence tertiary amine should be more basic than secondary amine, and secondary amine should be more basic than primary amine, and primary amine should be more basic than what? Ammonia. Because alkyl group are having what? Plus I effect, electron donating, electron releasing, electron pushing inductive effect. Okay, so they are increasing electron density over what? Nitrogen atom. This what is mentioned here, due to increasing inductive effect of successive alkyl group. Successive means what? Here we have added one alkyl group, here we have added two alkyl group, here we have added three alkyl group. Due to increasing inductive effect of successive alkyl groups, making the nitrogen atom more electronically dense, isn't it? Hence tertiary amine should be stronger bases than secondary, and secondary should be stronger than what? Primary. So see here, this is the series. First series, blue series, I can say here, methylamine series here, methyl series here, ammonia. Methylamine is having pK 10.64, pKAH, this is what? pKAH. Ammonia is having pKAH 9.25, while dimethylamine is having pKH 10.77, while tertiary amine is having pK 10.80. As we have already discussed in last slide, okay, the pK values, suppose pKAH values are more, that means that is what? More stronger base. So tertiary amine here, trimethylamine is more stronger base here, okay, than what? Dimethylamine. And dimethylamine is more stronger base than methylamine, and methylamine is more stronger base than what? Ammonia. Now see second series. In second series we are having what? Ethylamine, which is having pKAH values 10.67, while this diethylamine, which is having pK value 10.93, and triethylamine is having pKAH value 10.88. 10.88. That means in series 2, series number second, that is in red series or in ethylamine series or a diethylamine series. Okay, so here secondary amine is more stronger, isn't it? Secondary amine is what? More stronger base than tertiary amine, and tertiary amine is more stronger base than primary amine. So here the order is somewhat not what we are expecting here, like that tertiary should be more than secondary and secondary should be more than primary. In series 2, secondary amine is more stronger, okay, secondary is more stronger than tertiary, and tertiary is more stronger than primary. Okay, now why is it so? Why is it so? This what we have to see. Okay, let us see. See, this is the same series here I have written. First series, methylamine. dimethylamine, trimethylamine. Trimethylamine is more basic in first series, that is tertiary amine is more basic in first series, while in second series secondary amine is more basic than tertiary, and tertiary is more basic than primary amine. So if we see both these series, it has been observed that the introduction of an alkyl group into ammonia increases the basic strength to a greater extent. Okay, as we are increasing electron density over nitrogen atom of ammonia by what? Keeping electron donating or inserting electron donating group like a alkyl group over that nitrogen atom. So that is increasing electron density to much greater extent. Now, the introduction of second alkyl group further increases the basic strength, but the net effect of inductive and the second alkyl group is very much less marked than with the first. Okay, so see the net effect here. Net effect means terms of what? See, ammonia in first series, ammonia is having pKh value 9.25. Ammonia in first series having pKh value 9.25. When we are introducing a first methyl group, one methyl group in methyl amine, so the pKh value is 10.64. that means how much it is increase? Around 10.64 minus 9.25. okay, so it is increase how much? Around 1.4. okay, it is increase around 1.4 unit. okay, but when we are having second 2 methyl group, okay, when we are inserting 2 methyl group in that nitrogen atom of methyl ammonia or ammonia, then there is just slight increase, there is just slight increase in the pK value. It is how much? 10.7 minus 10.64, so it is 0.13, almost how much? 0.13. in case of first methyl insertion, the value is how much? Around 1.4 unit. pKh increase in pKh value is around 1.4 unit. By the insertion of second methyl group, the value is increases just marginally, just by 0.13. and in case of third insertion of methyl group, the value is just increased by what? 0.03. it just increased by what? How much? 0.03. okay, just 10.80, 10.77, like that. So but the net effect of introducing second alkyl group is very much less than the first. okay, again we can say here the introduction of third alkyl group to get a tertiary amine, however, actually decreases the basic strength in second series. okay, that is decrease this basic strength in what? Second series is quoted. That means the basic strength of amine, basic strength of amine in aqueous medium is not only determined, the basic strength of amine, okay, in the what? Aqueous medium is not only determined on the basis of electron availability, on the basis of electron availability on the nitrogen atom, but also on the what? Stabilization of conjugate acid of the base through what? Solvation. okay, so that means we cannot say basicity of amine is completely dependent on how much the lone pair is available for protonation. okay, so it is not completely depend upon how much the lone pair is available for what? Protonation. It is also dependent on what? After donation of lone pair, after sharing of that lone pair, after accepting of proton, there is what? Formation of a conjugate acid. If that conjugate acid is stabilized, if that conjugate acid is stable, then and then only that amine will be what? More basic. That means for a basicity of amine, there are two factors. One is what? It should donate or it should accept a proton. okay, it should donate a lone pair to what? Proton very easily, or we can say it should accept a proton very easily. This is the what? First factor. And second factor is what? After acceptance of a proton or after donation of a lone pair to what? Proton, there will be what? Formation of conjugate acid, and that conjugate acid should get what? Stabilized very well. okay, So stabilization of conjugate acid and acceptance of proton, these two parameters, these two factors is good, that amine will be what? That amine will be more basic than the other amine. So in case of second series, secondary amine is more basic than the primary amine. Secondary amine is more basic than the tertiary, and tertiary is more basic than the primary. But in case of first series, tertiary amine is more basic than secondary, and secondary is more basic than primary. Now see how already we have discussed this. The expected order of acid basicity is like this: tertiary should be more than secondary, and secondary should be more than primary, and primary should be more than ammonia. Now see, due to increasing inductive effect of successive alkyl group, due to increasing inductive effect of successive alkyl group, making the nitrogen atom more electronically dense, hence tertiary should be more stronger than secondary, and secondary should be more stronger than primary. This is what we have already discussed. But see here, after donation of proton, sorry, after acceptance of proton, primary amine is forming such type of conjugate acid. Okay, after acceptance of proton, secondary amine is forming such type of conjugate acid, and after acceptance of proton, tertiary amine is forming such type of conjugate acid. Okay, now see, this is what conjugate acid of a primary amine, this is what a conjugate acid of a secondary amine, and this is what a conjugate acid of a tertiary amine. So if we see, conjugate acid of primary amine is more stabilized. Conjugate acid of primary amine is what? More stabilized than the conjugate acid of secondary amine, and conjugate acid of secondary amine is more stabilized than the conjugate acid of tertiary amine. Why? Because in case of conjugate acid of primary amine, there are what? Three solvent molecule like water, they are forming intermolecular hydrogen bond with these three hydrogen atom, with this what? With these three hydrogen, or with these three proton of primary conjugate acid of primary amine. Okay, so here there are three stabilizing intermolecular hydrogen bond in case of conjugate acid of primary amine, and in case of conjugate acid of secondary amine, there are how many intermolecular hydrogen bond? Stabilizing intermolecular hydrogen bond, just two. Okay, and in case of tertiary amine, stabilizing intermolecular hydrogen bond of conjugate acid is how many? Just one. It's just one. So tertiary amine, conjugate acid of tertiary amine is what? Conjugate acid of tertiary amine is what? Not well stabilized. Conjugate acid of tertiary amine is not well stabilized through solvation. Okay, while conjugate acid of primary amine is well stabilized through solvation, but electron density is more available on nitrogen atom of tertiary amine. Hence the two effects are operating like this. Okay, see, the inductive effect is operating like this, and solvation effect is operating like this. So both of them are operating in opposite direction. Both of these, that is, inductive effect is increasing electron density on nitrogen atom. Okay, and solvation effect is operating like this. If tertiary amine is there, that will be what? That will be a conjugate acid of that tertiary amine will be what? Less stabilized. Okay, hence the both the effect, that is inductive effect, which is increasing electron density on nitrogen atom, that is more in what? Secondary amine. And there is also what? Stabilization. There is also what? Stabilization through what? Solvation. Stabilization through what? Solvation is also present in secondary amine. Hence secondary amine, as a net effect, secondary amine is more stronger than tertiary, and tertiary is more stronger than primary, because secondary is having marginal effect of stabilization of conjugate acid, and also there is increase of lone pair, that is increase of electron density is also there. Okay, so both the effect are good in what? Secondary amine, hence secondary is more stronger than tertiary and tertiary is more stronger than primary. So expected order is like this, but experimental order is like this. Experimental order is like this. Secondary is more stronger than tertiary and tertiary is more stronger than primary, isn't it? So let us see next slide. More stabilization of the conjugate acid, we can say more stabilization of conjugate acid, the corresponding base will be more stronger. Okay, thus from ammonia to tertiary amine, the inductive effect will tend to increase the basicity, but progressively the less stabilization of cation, that is conjugate acid, is less stable in case of tertiary amine. By solvation will occur, which will tend to decrease the basicity, which will tend to decrease what? Basicity. In case of tertiary amine, inductive effect is increasing basicity, no doubt, but there is what? Progressively less stabilization of cation of a conjugate acid of what? Tertiary amine by solvation, because there is just only one proton. There is what? Just only one proton in tertiary amine, and that will get bonded to what? Hydrogen bond through what? Intermolecular hydrogen bonding. So if we measure the basicity, now next is what? If we measure the basicity in a solvent where the hydrogen bonding cannot take place, where such type of hydrogen bonding, where such type of solvation, where such type of solvation is not possible, then the basicity of amine, order of basicity of amines is different. See, it's like this. Basicity of butyl amine in chlorobenzene, basicity of butyl amine in chlorobenzene. So tertiary butyl amine is more basic than secondary amine, and secondary is more basic than primary amine. Okay, so why? Because here chlorobenzene is not a solvent. Okay, and that is not forming, chlorobenzene is a solvent, but that is not a polar solvent, that is not a polar solvent. Okay, polar protic solvent, so it is not helping in stabilization of conjugate acids of what? These bases. Okay, hence the order is like this. Tertiary butyl is more basic than secondary butyl amine, and secondary butyl is more basic than primary butyl amine. Okay, so basicity of amines is dependent upon what? Is dependent upon what? How effect, that is electron donating effect of alkyl group, increasing electron density on nitrogen atom, and second factor, stabilization of conjugate acid by solvent molecule. Okay, so when both these effect are there, stabilization of conjugate acid by solvent molecule and increase of electron density on nitrogen atom, that base will be what? Stronger base. Okay, so I hope you have understood this topic. Okay, so we'll stop here. In the next lecture we will continue with again basicity of amines. Okay, so we'll stop here. Thank you.